Hi everyone, this is a video for Math 105, and as is written here, the idea is to do a couple examples from section 1.5 using a particular technique for solving quadratic equations, and that's called by taking the square root. This one doesn't always work, but for particular problems, it's really nice and easy. So that, kind of recognizing a particular quadratic equation where you can do this kind of sets you up for, think of it as a shortcut kind of way. So 26 and 31 are two examples. So let's just get to it. So 26 is x minus 1 quantity squared equals -9. So notice you've got something all by itself squared. Now it's not just x squared, it's this quantity squared equals, and on this side you want just the number. You don't want no instances of x's. So no x here. So that's kind of the setup. So when you have that thing, something squared equals a number, then you can use this idea, and the idea is very simple. You just take the square root of both sides. Now, a lot of times we say, hey, this is -9. We can't take the square root of that. But remember, we're allowing complex numbers. So if I do this, then what you have is, okay, so now x plus 1 equals, and the big thing here is you have to do plus or minus. There's two possible square roots. So if you take the square root of something squared, you just get that thing, but it equals plus or minus. So I guess you could put the plus or minus on this side. I like to put it on that side. Okay. And now you just have to kind of finish the work here. Square root of -9. So think of the square root of -9 as equal to the square root of 9 times the square root of -1. And the square root of 9 is 3, and the square root of -1 is I. So that's 3i. So we've got x minus 1 equals plus or minus 3i. And now you just add the 1 to both sides, and x is 1 plus or minus 3i. And notice, this is again shortcut for x equals 1 plus 3i, or x equals 1 minus 3i. And the thing to keep in mind with quadratic equations is when you do have complex number solutions, they always come as a pair, and the pairs are conjugates. So it's a plus bi, a minus ei when they're complex numbers. Okay, let's try one more. 31. So 31 is the quantity 5x minus 1 squared equals, this time, +7. So again, we get the same setup. I've got something squared. So this thing squared equals a number. So now that's what you want. Take the square root of both sides, the square root of something squared, just get that thing. Well, actually, you get plus or minus that thing. This is the square root of 7. So take the square root of something squared, get that thing, as long as you put a plus or minus. Square root of both sides. Okay. I want to solve for x now, so I add 1 to both sides. And then divide both sides by 5. So x is 1 plus or minus the square root of 7 over 5. And you notice this kind of answer, 1 plus or minus the square root of something over a number, that reminds me anyway, a lot of what you get if you plug numbers into the quadratic formula. So the fact that you get something like this makes sense, because if you would have expanded this out and solved it by the quadratic formula, then it makes sense you'd get that. And in fact, even though it didn't ask for it, let's do that to kind of show. So if I wanted to solve this by the quadratic formula, I'd have to first expand this out. And notice that's 5x plus minus 1 times 5x minus 1. So 5x times 5x is 25x squared. And then I get 5x minus 1 is minus 5x. Minus 1 minus 5x. And then minus 1 times minus 1 is plus 1 equals 7. So I have 25x squared minus 10x plus 1 equals 7. Subtract 1, 5x, subtract 7 from both sides. And I'd get 1 minus 7 is negative 6. And that's because, again, if you're using a quadratic equation, you need it to be equal to 0. So this is what I need for the quadratic equation, which is x is minus b plus or minus the square root b squared minus 4ac all over 2a. So plugging a is 25, b is negative 10, c is 6. We get x equals, the opposite of negative 10 is plus 10. B squared, negative 10 squared is 100, minus 4 times 25, that's 100, times negative 6, that's negative 600. But negative 600 plus, yeah, that's plus 600. And that's all over 2 times a, 2 times 25 is 50. So let's see, this gives me x is 10 plus or minus the square root of 700 all over 50. And now, I'm going to reduce 700 is 100 times 7. So this is 10 plus or minus the square root of 100 times the square root of 7. Well, the square root of 100 is 10. There. And now the 10 and the 10 and the 50 all cancel and leave me with 1 plus or minus the square root of 7 all over 5. And voila, that's the same. Yay, that makes me happy. So notice, if you use the quadratic formula, it's a lot more work because you have to do all this stuff first and the numbers are awkward. If you use by squaring, by taking square roots, it's a lot faster. So that's the nice thing about the taking square roots one. It doesn't always work, kind of like factoring doesn't always work. But in the cases where it does work, it's generally a shortcut. So quadratic formula always works. Other methods might not always work, but when they do work, they're often shortcuts. Okay, thank you.